All right, this is going to be part 2 of how to draw triangles. Again, these are from word problems and they can get kind of difficult. And the way to do it is to draw nice pictures. So let's go ahead and get started. I'm on number 8 here. So there's this, they're looking at a ski lift. It's at the top of the mountain. And so there's this guy measuring angles and stuff. And so he's standing, we'll say he's standing here. And he's looking up to this top of the mountain, right? Here's the top. And when he looks at that top of the mountain, he sees an angle of 25 degrees. Okay. He then walks back away from the mountain. So he's walking this direction and he walks 1,000 feet. 1,000 feet. And he looks up at the top of the mountain. And now this angle is 15 degrees. And so that right there should be everything you need to solve this triangle, because you'll go find this angle, then you'll know this angle, then you can do law of sines. So that's how you would do that one. The next one, they're looking at a missile launching. So there's some missile, we'll say here, and they say it's vertically ascending. That means it's going straight up like this. All right, so there's this missile going up. And there's this guy watching. Here he is. And when he first sees it, he sees that at an angle of 21 degrees. And when he sees it the second time, the angle total is 35 degrees. So that makes this 35 minus 21 is 14 degrees. Okay. And oh, by the way, he's 2 kilometers away. So 2 kilometers. And that right there should be enough you need to solve this triangle, because if it launches straight up, that makes this a right angle. And then this becomes pretty easy. So the next one, there's this bridge and it's over this gorge. And so basically we'll say here's the bridge. And there's guys standing at either end of it, and they're looking down into the gorge. And one of them, when they look down, sees 69.2 degrees. And the other guy, when he looks down, sees 65.5 degrees. And the two people are 880 feet away from each other. So that right there is everything you need for this triangle. This one, I would go get this angle, and then you can run law of sines. All right, next one. Golfer hits an errant tee shot. So I teed off and it didn't go well, and it landed here. I want to make it look a little nicer. It lands here. Okay, now I was trying to go to the green, G. I'm trying to go here. But I see that there's this marker away from the green here. Here's the marker. So this is what my triangle is going to look like. And basically the marker is 150 yards from the green. So I know this is 150. And when I'm standing here at the marker, so I'm at M here, and I look back towards my ball, which is here, it's 110 degrees. So that means this angle right here is 110 degrees. And then I walk 35 yards to the ball. So this length is 35. And so this, I would run law of cosines on this problem. You can't do law of sines on that because you don't have a corresponding degree angle measurement and distance. So run law of cosines. All right. Okay, this next one, there's a cruise ship and it's trying to get from Puerto Rico to Barbados. And so here's San Juan, Puerto Rico, S. And it's trying to get to here, Barbados. But there's a storm in the way. So they're going to go off route some and then come back to get to Barbados. So it's going to look something like this. Now, to avoid that storm, the captain headed out 20 degrees off course. So that angle is 20 degrees. And he maintains this for 10 hours at 15 knots. Well, that puts him 150 nautical miles away from San Juan. And then the last piece of information that they'll give you is the total distance from Puerto Rico to Barbados, from San Juan to Barbados, is 600 nautical miles. So that whole distance is 600. So that's the triangle you need to solve that one. That is a law of cosines. Okay, next up, there's a CB radio operator. We'll say he's here. And he has a base on Farm Road 1984. So here's the road. All right, and there's another road, Highway 87, that intersects. So there's going to be another road here that intersects. And where he is at, where he currently is 8 miles from that intersection. Now, the farm road makes an angle of 32 degrees with the highway. That means this angle right here is 32 degrees. Okay, now they're saying if the radio has a range of 5 miles, what two distances could they hear him? What that means is there's going to be a triangle here, and then there's also going to be a triangle there. This is a double triangle problem. So you kind of have to figure out both possibilities. So the only thing that you have to work with is that this blue line is 5 miles. And basically that's all you need. You just kind of make 2 triangles out of it and go find this distance first, and then go find this total distance second. So, all right, moving on. This problem's so weird because they just say, as Ivan approaches 2 satellites. So I guess there's this guy named Ivan, and he's floating in outer space. So we'll say he is here. And he sees 2 satellites. So we'll say one's to his, it doesn't really matter how you draw these to scale per se. You just care that your angles and distances are correct. So he sees 2 satellites. One of them is 8 kilometers and one of them is 11 kilometers. So my triangle is going to look something like this. And one of them's 8 and one of them is 11 distances from him. And it also says the angle between the two using Ivan as the vertex. So this angle right here is 120 degrees. And so now you're ready to solve that triangle. That's a law of cosines. All right, and then this last one, Ivan's still floating, I don't know, around the Earth. He sees the satellites again. Well, just one of them this time. So we'll say Ivan is here now. And he sees a satellite over here. This is the one he sees. And then there's another one that he doesn't see. So he sees that right there. He estimates that the angle between the satellite he can see and the satellite he can't see, we'll say it's here, can't see. Okay. He says that this angle is 37 degrees, 43 minutes. So this angle is 37 degrees, 43 minutes, like that. And the angle at the visible satellite is 113 degrees. So that means this angle is 113 degrees. The distance between himself and the satellite he sees is 4,362 kilometers. And so now I have everything I need to solve this triangle. I'd go get this angle and then run law of sines. So I hope that helps clarify how to draw some of these triangles. It can get really tricky. Draw a nice picture. Be careful with it. Again, it doesn't matter the scale necessarily. What matters is that your numbers are correct. So hope this video helped.